करणार नाही. नेक्स्ट घ्या नंबर आरती सुनील मल्हा आहेत का प्रेझेंट? आरती सुनील.
येस मॅम.
ओके व्हेरी गुड. पण तुम्ही कंटिन्यू चला स्क्रीन शेअर करा आणि स्टार्ट करा.
मॅम पीपीटी नाही तयार केली.
ओके मग काय केले? रिपोर्ट केलाय का वन पेज?
मला वाटलेलं की फक्त सिनॉप्सिस करायचे म्हणून मी सिनॉप्सिस केला आणि दिलेली त्या लिंक वर सबमिट केलं.
ओके नो प्रॉब्लेम. सिनॉप्सिस जे काय आहे ते परत शेअर करा आणि तुमचा जो टॉपिक आहे तो एक्सप्लेन करायला सुरुवात करा. ठीक आहे चला स्टार्ट करा. हां हॅलो काय झालं आरती? शेअर करा पटकन, वेळ घालवू नका. ओके तुम्ही तुमची सेटिंग करून ठेवा. होतंय का तुम्हाला?
हा करते पण ते होत
ओके
नाहीये म्हणजे
स्टार्ट करा.
करतेय.
तुमचा काय टॉपिक आहे तो सांगा आणि स्टार्ट करा चला.
बेसनर प्रोसेस घेतलाय मी.
ओके रोल नंबर सांगा आधी. इंट्रोडक्शन द्या तुमची.
5312 रोल नंबर आणि UID नंबर 2018-10-180. माझं नाव आरती सुनील मल्लाह.
टॉपिक नाव सांगा.
टॉपिकचं नाव आहे बेसनर प्रोसेस.
ओके करा कंटिन्यू करा चला.
चालू करू?
येस येस.
हॅलो.
हा चालू करा चला स्टार्ट करा.
The Bessemer process is proposed by Sir Henry Bessemer in 1856 and is used to manufacture the steel. म्हणजे 1856 मध्ये सर हेनरी यांनी बेसनर म्हणजे त्यांनी हे प्रस्तावित केलेली आणि बेसवर कन्व्हर्टर नावाच्या मोठ्या म्हणजे अंड्याच्या आकाराच्या भांड्यात ही प्रक्रिया केली जाते. जी स्टीलच्या प्लेट्स पासून बनवलेली असते. म्हणजे कसं द प्रोसेस म्हणजे ते आता प्रोसेस सांगते. द प्रोसेस इज carried out in large egg-shaped vessels called Bessemer converter, which is made up of steel plates and lined with siliceous material. When acidic impurities are removed, a basic line आणि त्यानंतर CaCO3 आणि MgCO3 is used, so it is called basic Bessemer process. When basic impurities are removed and acidic line SiO2 is used, so the process is called as Bessemer process. म्हणजे जेव्हा ऍसिडिक अशुद्धी म्हणजे डोलोमाइट होते त्यात अस्तर काढून टाकली जाते त्यातली तेव्हा त्याला मूलभूत असं म्हणतात. आणि मूलभूत अशुद्धता काढून टाकण्यासाठी जेव्हा CO2 ची एक ऍसिडिक अस्तर वापरली जाते म्हणून त्या प्रतिक्रियेस अशी ऍसिडिक बेसमर प्रक्रिया अशी म्हणली जाते. Then converter is mounted on trunnion so that it can be tilted into different position according to requirement. मग तिथून कन्व्हर्टर ट्युनिंगवर आरोहित केले आहे जेणेकरून म्हणजे केले जाते जेणेकरून ते आवश्यकतेनुसार विविध पदार्थांवर शीर्षक केले जाऊ शकते. आणि ह्याचे वर्किंग आहेत द बेसमर कन्व्हर्टर इज tilted into horizontal position and about 15 to 20 tons at molten cast iron from the blast furnace are run into converter. म्हणजे परत त्याच्यातून बेसमर कन्व्हर्टर क्षितिज स्थिती म्हणजे एकदम स्थितीत वाकलेले असते आणि
ओके ठीक आहे स्टॉप.
आणि कन्क्लुजन पण म्हणजे सांगूय.
नाही नाही ठीक आहे असू दे. ठीक आहे नेक्स्ट.
मॅम तुमचा आवाज येईना मला.
हा ठीक आहे आरती थँक्यू.
थँक्यू मॅम.
ओके नेक्स्ट बघा माने 182 यूआयडी नंबर 2018 10 182 आहात का प्रेझेंट.
Yes, ma'am.
ओके व्हेरी गुड. शेअर करा स्क्रीन तुमची. मृण्मयी स्क्रीन शेअर करा.
मी स्क्रीन दिसतीये.
येस येस दिसते.
हा मी स्टार्ट करू ना मिस.
येस येस ऑल द बेस्ट.
थँक यू मॅम. Good afternoon, everyone. Myself Mrinmayi Mane. My roll number is 5315. UID number is 2018 182. My topic for seminar is Lewis concept.
53
G.N. Lewis in 1923 defined Lewis concept as it says acid is an electron pair acceptor and base is an electron pair donor. Let's see what it means. Since Lewis acid is electron pair acceptor, it is called electrophilic reagent or electrophyte, which means it is electron lover. It accepts electrons. For this, it should have one or more vacant electrons in its valence shell, that is, it should have low energy atomic or molecular orbitals. Lewis base is an electron pair donor. It is electron rich species and it is positively charged. It donates electrons, so it is nucleophilic reagent or nucleophile. For this, it should have at least one lone pair of electrons that is occupied relatively high energy atomic or molecular orbital. Reaction between Lewis acid and Lewis base is called neutralization. Neutralization between Lewis acid and Lewis base involves formation of coordinate covalent bond. The product of these can be adduct, complex or coordinate compound. For example, Lewis acid, that is boron trifluoride plus Lewis base, that is ammonia, gives adduct acid base adduct. Now let's see classification of Lewis acid. Classification of Lewis acid uh, is classified into two types. Simple cations. All cations, carbocations are classified into Lewis acids. For example, Zn2 plus, Ag2 plus. Smaller cations like H plus and Ag plus behave as strong acids. Larger cations like Na plus and K plus behave as weak acids. Incomplete octet compounds is also classification of Lewis acids, which means molecules in which central atom have incomplete octet in their valence shells. They accept electron pair to complete the octet. For example, boron trifluoride. Classification of Lewis base. All ions act as Lewis bases. For example, chloride ion, bromine ion, cyanide ion. Next classification is neutral molecules. Neutral molecules means whose central atom has one or more lone pair of electrons, which can then donate electrons and act as Lewis bases. Halides is also classification of Lewis bases. For example, xenon difluoride, cobalt chloride. Merits of Lewis concepts are this concept is more general. Substances which are not classified as acids and bases in Arrhenius and Cronstedt concept brought under by Lewis concept. Lewis concept include formation of coordination compound as acid and base reactions. There are also some demerits for Lewis concept. These are it fails to account relative strength of acids and bases. In acid and base reaction, there is electron transfer, so the reaction should be fast, but some reactions are slow. These are some demerits. Thank you.
Okay, very good, Mrinmai. Tell me, what are you called ammonia or Lewis base?
I didn't get the question, ma'am.
Okay, why you called ammonia or Lewis base? Why? Reason?
Because it is Lewis base because it has a lone pair of electrons in its valence shell.
Okay, म्हणून Lewis base.
Yes,
Or trifluoroboron, Lewis acid. Why called?
it is Lewis acid. It is Lewis acid because it has it is incomplete octet in their valence. It is not complete octet.
Okay, tell me hybridization of trifluoroboron.
I don't know, ma'am.
Okay, okay, ठीक है. Very good. Thank you.
Thank you, ma'am.
Okay, next. अक्षय मोरे. अक्षय मोरे 2018 10 189. अक्षय मोरे आहात का
हो येस
प्रेझेंट?
मॅम
ओके, व्हेरी
आहे.
गुड. येस येस येस, स्क्रीन शेअर करा.
मॅडम
येस.
म्हणजे माझा रोल नंबर आहे त्याच्या अगोदर.
ठीक आहे, असू देत, आपण घेऊयात, काही प्रॉब्लेम नाही. त्यांचं झालं की घेऊयात. सगळ्यांचे होणार आहेत, तुम्ही जे काही जॉईन झालेत. माझ्याकडे जी काही लिस्ट आली त्याच्यानुसार मी चाललीये. जे काही मध्ये आधी राहतील त्यांना आपण खाली ऍड करूयात, काही प्रॉब्लेम नाही.
मॅडम
येस येस, स्क्रीन दिसते. व्हेरी गुड.
दिसतंय.
येस, दिसतीये. व्हेरी गुड. ऑल दी बेस्ट.
थँक्यू मॅम. माय सेल्फ अक्षय रामचंद्र मोरे. माय रोल नंबर इज 5323 अँड UID नंबर इज 2018-10-189. माय सेमिनार टॉपिक इज मॅन्युफॅक्चरिंग ऑफ नॅप्थलिन बॉल्स. Introduction. Naphthalene is an organic compound with formula C10H8. It is the best known as main ingredient of traditional math ball. Math ball are commonly made of naphthalene or para-dichlorobenzene, both of which are toxic to humans. Thus, chemical are solid at room temperature, are made into round ball plaques or cakes that slowly change to the gas and become
मोरे
fused in
एक मिनिट,
red.
सॉरी डिस्टर्ब करते बघा. तुमचा स्क्रीन आहे की नाही, स्क्रीन
हा
ती की नाही हॉरिझॉन्टल ठेवा मोबाईल, म्हणजे फुल स्क्रीन दिसेल.
ठीक आहे मॅडम.
हा हा, आणि पूर्ण स्क्रीन वरती म्हणजे तुमची ती स्लाइड येईल.
मॅडम होत
ओके
नाही.
ठीक आहे. बरं बरं ठीक आहे. असू द्या असू द्या. करू टू बी कंटिन्यू.
हा. There is the chemical of naphthalene ball are the solid white balls which are the composed of the crude oil, coal tar and other chemical are used as the preservative to protect cloths from the rodents. Naphthalene is also used in production of the phthalic anhydride, and sometimes it is also act as synthetic tanning agents and as an intermediate in dyes. And इलेक्ट्रिक नॅप्थॉलिन बॉल मेकिंग मशीन ही इलेक्ट्रिक मशीन आहे. नॅप्थॉलिन बॉल तयार करण्यासाठी त्या मशीनच्या सहाय्याने आपण इझिली नॅप्थॉलिन बॉल तयार करू शकतो आणि मोठ्या प्रमाणात तयार करू शकतो कमीत कमी वेळेमध्ये. तर रॉ मटेरियल ह्यासाठी लागतं नॅप्थॉलिन, फ्लास्क, कापूर आणि फेनॉल. द मोस्ट इम्पॉर्टंट रॉ मटेरियल of you at the beginning of this business will be naphthalene powder, which is cost rupees 150 per kiptia 1 kg. Apart from this, you will need oil, kapoor wax and soft stone its. For this, apart from the raw material, you will also need this ball making machine and packing material. मॅन्युफॅक्चरिंग मॅन्युफॅक्चरिंग ऑफ मॅथ बॉल करताना पहिल्यांदा जी नॅप्थॉलिन पावडर आहे ती त्याच्या सहाय्यानं आपण नॅप्थॉलिन पावडर त्या मशीन मध्ये पहिल्यांदा ही करायची आणि ती मशीन आपण 88°C ह्याच्यावर टेम्परेचरला ती सेट करून घ्यायची. त्यानंतर ते नॅप्थॉलिन पावडर एक मिक्स झाल्यानंतर ती कम्प्लिटली मेल्ट करायची त्या मशीन मध्ये. त्यानंतर त्यामध्ये कपूर आणि वॅक्स ऍड करायचा. ते सोल्युशन तयार झाल्यानंतर ते आपण ते सोल्युशन रेडी होतं. त्यानंतर ते सोल्युशन आपण कूल करण्यासाठी एका अल्युमिनियमच्या कंटेनर मध्ये ते ठेवायचं आणि त्यापासून नंतर ना ते बॉल तयार करा, नॅप्थॉलिन बॉल तयार करायचे. तर यूज ऑफ नॅप्थॉलिन बॉल मॅथ बॉल आर क्लासिफाइड ॲज पेस्टिसाइड अँड यूज टू कंट्रोल मॉथ्स, सिल्वरफिश अँड अदर फायबर पेस्ट्स in wool and other natural fibers, cloths and materials. Naphthalene balls are quite potent to keeping out moth larvae and other insects from your clothes. Thus naphthalene balls come in different colors and looks good as well as do their job well. Keep your clothes protected with homemade naphthalene balls. Thank you, madam.
Very good, More. Okay, tell me boiling point of naphthalene.
Nap-
Okay, it is a water soluble or insoluble?
मॅडम इट इज इनसोल्युबल वॉटर. सॉलिड मध्ये असत आणि त्याच्या ज्या सॉलिड मध्ये असतात आणि ज्या फ्युम्स निघतात ना
हा.
त्यामुळे क्लॉथ प्रोटेक्ट होतात.
ओके ओके ठीक आहे. थँक्यू.
वेलकम.
नेक्स्ट हर्षदा मोरे.
Yes, ma'am.
ओके, शेअर युअर स्क्रीन. 2018-10
Screen दिसते का miss?
येस दिसते. ओके, स्टार्ट. ऑल द बेस्ट.
Thank you, miss. Good afternoon, everyone. Myself, Harshada Lakshman More. Roll number 5324. UID 2080 10 190. My topic for seminar is define steel and types of steel. First, define steel. Steel may be as it is the most important form of commercial iron by removing some carbon along with sulfur, phosphorus, silicon, or by adding the required quantity of carbon to wrought iron. Generally, steel is free from phosphorus, silicon, and sulfur. Its physical property depend upon chemical composition and also heat treatment. Types of steel. There are two types of steel. Carbon steel is divided into three types. First, mild steel. This type of steel contains less than 0.2% of carbon content. It is malleable, ductile, and used in place of wrought iron. It is used in boiler plates, rivers, etc. This is the example of mild steel. Second, medium steel. Medium steel contain carbon content 0.2 to 0.6%. It is used for making rail structure elements such as beams, etc. It is also called as structural steel. Third, high carbon steel. This type of carbon content ranging from 0.75 to 1.5%. It is also called as hard or tool steel and used for making tools, files, surgical instruments, drills. This type of steel can be also obtained by quenching the mild steel. This is the example of medium steel and this is the example of high carbon steel. Second, alloy steel. Steel when allowed with at least one other element than carbon in a sufficient quantity of confer special property on it called alloy steel. Elements used for this purpose are silicon, vanadium, titanium, chromium, manganese, tungsten, cobalt, nickel, etc. and are used in the production of alloy steel with desired physical and mechanical property. Sometimes more than one of these elements are used. Thank you, Miss.
Okay, ठीक आहे. What is mean by align? More, what is mean by alloy? Tell me definition. Okay. Which metal used in steel? Metal. ओके जे काही स्टेनलेस स्टील आपण यूज करतो डे टू डे लाईफ
Carbon.
मध्ये कार्बन मेटल आहे का मोरे ओके ठीक आहे थँक्यू नेक्स्ट मुस्कान मुलानी
Yes, ma'am.
येस शेअर युअर स्क्रीन येस दिसते स्क्रीन
Good afternoon, everyone. Myself Muskan Mulali. My roll number is 5327 and UID number 2018-10192. My seminar topic is polymer and their types and some synthetic polymer. Ma'am, audible?
येस यू आर ऑडिबल येस टू बी कंटिन्यू
Polymer. It is a compound of high molecular weight formed by union of a large number of molecules of one or two type of low molecular weight, that is monomer, and the process involving the formation of polymer is called polymerization. Now here are some types of polymers which are classified on the basis of origin. These are natural polymers, synthetic polymer, and semi-synthetic polymers. Natural polymers occur in nature and can be extracted, and they are often water-based. For example, naturally occurring polymers are silk, wool, cellulose, and proteins. Synthetic polymers. Synthetic polymers are derived from petroleum oil and made by scientists and engineers. For example, nylon 66, polythene, And semi-synthetic polymers are made by modification of the properties of natural polymers. Some important examples are nitrocellulose, cellulose acetate, etc. On the basis of intermolecular forces, the polymer are classified into elastomers, fibers, thermoplastic, thermosetting. Elastomers are the rubber or rubber-like polymer. The polymer having high degree of elasticity. In elastomers do not contain highly polar group or site for hydrogen bonding. They soften on heating. Natural rubber is elastomer. The polymer chain are held together by very weak intermolecular forces that can be easily overcome. Fibers. Example of fiber is nylon 6,6. Thermoplastic. Thermoplastic. They are the polymers which soften on heating and stiffen on cooling. In this softened state, they can be extruded or molded to any shape which is retained on cooling. This process of heating, reshaping, and retaining the shape on cooling can be repeated several times without decomposition or change in chemical composition of polymer. The intermolecular forces of attraction are stronger than in elastomers, so heating is needed to soften them. The example of thermoplastic is PVC. Thermosetting. They are the polymers which change to an infusible and insoluble mass on heating. These polymers are normally made from relatively low molecular mass semi-fluid polymers which on heating in a mold from extensive cross-linking between different polymers chains, forming the three-dimensional network to become insoluble hard mass. If thermosetting are heated above critical temperature, then these are converted into permanent hard from which cannot be recycled. Now some examples of synthetic polymers are polythene, polystyrene, Teflon, polyvinyl chloride and nylon 66. Thank you, ma'am.
Okay, very good. Tell me any two examples of presence of phosphorus polymer. Yes, येतंय?
नाही ma'am.
ओके ठीक आहे. थँक्यू मुलांनी. नेक्स्ट
Thank you.
प्रियांका नलवडे.
Yes, madam.
ओके व्हेरी गुड. नलवडे शेअर करा स्क्रीन तुमची.
Yes, ma'am.
रोल नंबर किती आहे?
This day, ma'am.
येस येस दिसते.
Good afternoon, ma'am. My name is Priyanka
गुड आफ्टरनून.
Roll number 5330. My seminar topic is acid and base. UID number 2018 10194. Acid. It is a substances that produce hydrogen ions when dissolved in water. All acids contain hydrogen, but not all substances with hydrogen contains acid. The hydrogen ion produced are responsible for the properties of an acid. Some common acids are man-made and natural acids. Man-made acids are hydrochloric acid, sulfuric acid, and nitric acid. Natural acids are ethanoic acid. Properties of acid. Acids have a salt taste. Acid dissolve in water to form solution and conduct induce electricity. acid turn blue litmus red pH value greater than 7. Use of acids, sulfuric acid and ethanic acid and hydrochloric acids. Sulfuric acid are used in detergent and car batteries. Ethanic acid are used in vinegar to preserve food and adhesive glue. Hydrochloric acid are used in cleaning metals and littering processing. Base the substance which produce hydroxide ion on water called a base. Example of base sodium oxide, zinc oxide and magnesium hydroxide, aluminum hydroxide. The family of bases are two parts, soluble and insoluble. Soluble are alkalis and insoluble in metal oxide and hydroxide. Alkalis. Definition of alkali. An alkali is a base that is soluble in water. Some examples: sodium hydroxide, potassium hydroxide, and calcium hydroxide, and barium hydroxide. Properties of alkalis. Alkalis have a bitter taste and soapy feels. Alkalis turn red litmus paper blue. pH value less than 7. Use of alkali are ammonia solution, calcium oxide and sodium hydroxide. Ammonia solution is used in window cleaning solutions. Calcium oxide is used in make iron concrete cement. Sodium hydroxide in making soap and detergent. Thank you, ma'am. Ma'am.
Yes, okay. Nanavade, what is the density of sulfuric acid? And tell me so proper range of pH sulfuric acid. Acid. Okay, tell me uses of acid in chemistry. Okay, ठीक है. Okay, thank you, Nanavade.
Thank
Next,
you.
Shubham Nikam, Shubham Vijay Nikam. Uh, okay, share your screen. Screen share करा ना. आवाज येत नाहीये तुझा. हॅलो, आवाज येत नाही तुझा. हा शुभम, आवाज येत नाहीये तुझा.
Am I audible?
हा येस.
Good afternoon, everyone. Today's topic is sources and types of fertilizer. My name is Shubham Nikam. Roll number is 5321. UID is 2018 198. fertilizers are the main source of the agricultural field, which supplies soil, plant for the nutrients to the growth of the plant. There are fertilizers are classified as straight fertilizers, complex fertilizers, mixed fertilizers. The straight fertilizers are those which supplies only one primary nutrient, such as nitrogen, phosphorus. Examples are urea, ammonium sulfate. The
ए
complex
हाय
contains two or more key primary plant nutrients.
निकम आवाज येत नाहीये तुमचा.
Mixed fertilizers typically mixed as straight fertilizers. Fertilizers can also be classified on their physical form: solid fertilizers and liquid fertilizers. Solid fertilizers consist of single superphosphate, which is
सोर्सेस
in
अँड
powder form,
प्रिपरेशन ऑफ फर्टिलायझर.
ammonium sulfate, crystals. Urea is in the form of cream, ammonium phosphate, superphosphate, granules, supergranules, which is
आउट ऑफ फाईव्ह.
liquid fertilizers are applied by using a spraying on it plant.
निकम झालंय का तुमचं?
Madam, network is
बरं ठीक आहे, असू देत असू देत. चला नेक्स्ट. स्वाती पाडोळे. स्वाती जगन्नाथ पाडोळे आहात का प्रेझेंट? भाग्यश्री संजय पवार.
येस मॅडम.
ओके, स्क्रीन शेअर करा तुमची.
दिसते का मॅडम?
येस येस दिसते.
My name is Bhagyashree Sanjay Pawar. UID number 280 10202. Roll number 5352. My seminar topic is cubic lattice and types of cubic lattice. These are the simplest unit cell. These unit cells are particularly important for two reasons. First, a number of ionic solids and metals have crystal lattice comprising cubic unit cells. Second, it is relatively easy to make calculation with these cells because in them all the sides are equal and the cell angles are 90. There are three types of cubic unit cells. First, simple cubic unit cell. Second, body centered cubic unit cell. Third, face centered cubic unit cell. First, a simple cubic unit cell is defined as it is one in which the atoms or ions are occupying only the corners of the cube. Thus, there are 8 points situated at 8 corners of the cube. Second, a body-centered cubic unit cell. It consists of 9 point, one at center and 8 are at the 8 comers. Third, a face-centered cubic unit cell. It consists of 41 at the center of each of 6 faces and 8 are at the 8 comers of cube.
ओके, नेक्स्ट धनश्री नानासो पवार. आहात का प्रेझेंट धनश्री पवार? ओके नेक्स्ट प्रतीक्षा नवनाथ पवार. प्रतीक्षा.
Yes,
हॅलो.
miss.
ओके शेअर युअर स्क्रीन.
Ma'am, is the screen visible?
येस येस.
Good afternoon, everyone. Myself Pratiksha. UID number 2018102005, roll number 5356. And topic for my seminar is neutralization of strong acid with a strong base. Let's take strong acid HCl and strong base NaOH. So in this neutralization process, zero point 0.1 normal HCl is titrated against zero point 0.1 normal NaOH. So the neutralization reaction for this titration is H plus Cl minus H plus Cl minus plus NaOH plus OH minus gives Na plus Cl minus plus H2O, which is neutral. You can see this reaction in the PPT. In this process of titration with addition of NaOH, neutralization of H plus ion takes place, due to which pH of the solution increases. The graph on the screen shows the titration curve of 25 ml, zero point 0.1 normal HCl with zero point 0.1 normal NaOH. The x-axis represents the amount of zero point 0.1 normal NaOH added, and y-axis represents the pH of the solution. You can see the pH increases slowly and steadily until about 24 ml base is added. With further neutralization of the acid, H plus of resulting solution decreases gradually, and so pH increases steadily. Near equivalence point, you can see there is rapid decrease in H plus, and each drop of zero point 0.1 normal NaOH produces relatively larger change in pH. And further, with excess of alkali added, it once again shows a slow and steady rise in pH. Thus, after equivalence point, there are only OH minus ions in the solution. So, the indicators having color change interval within range of sudden pH change on titration curve, that is at equivalence point, will be methyl orange, methyl red, and phenolphthalein, etc. So why this is necessary? Because um it will give the smallest titration error if occurred. Means the determination of the indicator is essential, so that even if a smallest change, smallest error will be occurred, it will be visible due to the indicator. Thank you.
ओके व्हेरी नाईस. नेक्स्ट ज्योती राऊत. स्क्रीन तुम्ही शेअर करायची तयारी करा. तोपर्यंत प्रतीक्षा नाही सॉरी नेक्स्ट श्रद्धा पवार आहात तुम्ही. तोपर्यंत प्रतीक्षा तुम्हाला क्वेश्चन आहे.
Yes, miss.
NaOH is a primary standard or secondary standard?
Primary standard. Uh, Actually, standard solution is HCl, and NaOH is the second standard solution.
Okay, why NaOH are secondary standard solution?
Because neutralization of H plus ions takes place.
Okay, okay, ठीक आहे. Tell me strong acid versus strong base titration pH range.
pH range 3 to 11.
Very good. Which indicator use this titration?
Methyl orange, methyl red, litmus, or phenolphthalein.
Why this indicator are used?
Because In the color change interval of sudden pH change, only methyl red, litmus, phenolphthalein, and methyl orange occurs.
No, no, no. My question is strong acid and strong base titration which indicator use?
Miss, will you please repeat the question?
स्ट्रॉंग ऍसिड वर्सेस स्ट्रॉंग बेस टायट्रेशन साठी कोणता इंडिकेटर तुम्ही यूज करणार?
Methyl orange.
कन्फर्म मिथिल ऑरेंज या फिनॉप्टेलिन या बोथ
Miss,
आर?
we can, no, both.
बोथ.
Yes, miss.
इज इट क्लिअर? टेल मी
Yes,
पीएच
miss.
रेंज. बोथ आर
3 to
इंडिकेटर.
11.
ओके, ठीक आहे. व्हेरी गुड. नेक्स्ट श्रद्धा पवार.
येस मॅम. चालू
ओके.
करू?
येस. प्रतीक्षा तुमचा रोल नंबर सांगताय का?
5356.
ओके. तुमचं सांगा श्रद्धा.
5362.
ओके, व्हेरी गुड. स्टार्ट.
गुड आफ्टरनून एव्हरीबडी. फर्स्ट ऑफ ऑल सर्वांना गुरुपौर्णिमेच्या हार्दिक शुभेच्छा. आय एम श्रद्धा पवार फ्रॉम
थँक्यू
BSc
श्रद्धा.
थर्ड इयर. थँक्यू मॅम. I am Shraddha Pawar in BSc third year. My roll number is 5362 and UID is 2018102007. Today I represent topic of seminar is pesticides. It include in agrochemicals. In India, India is a agricultural country. We are bearing from agricultural background. In India, 70% of people depends on farming. So we also know from farmer related chemicals. My topic is one of these agrochemicals, pesticide. Pesticide. First of all, we see definition or information about pesticide. A pesticide is a substance or mixture of substance intended for preventing, destroying, repelling, or lessening the damage caused by the pest. A pesticides can be insect, plant, pathogen, weeds, bacteria, birds that complete with humans for food, destroy properties, spread diseases. A pesticides can be chemicals, biochemicals agent, antimicrobial, disinfectant, etc. Many chemicals pesticides are poisonous to humans and animals. Second is chemicals or synthesis pesticides. Organochlorine. These are the non-biodegradable and persist in a soil for a long time. For example, DDT, BHC. DDT means dichlorophenil trichloroethane. Organophosphate. These are the ester of alcohols with phosphoric acid with some other acids. These are very toxic acetyl chlorine ester inhibitors as a result of which of the breakdown of acetylcholine stops. The accumulation of acetylcholine resulting in convulsion, paralysis, and death. For example, maltine, carbamide. They are divided from carbamic acid mode of action of carbamides. It is similar to organophosphate. For example, carbamyl, dimethyl. Second is a working of pesticide. Pesticides work in a following way. By blocking of the cellular process of the target organisms is a purely mechanical way, that is spray oils, petroleum oils. By, by destroying or altering the pest metabolism. For example, rotenone and cyanide, which disrupt respiratory function of the face. By disrupting enzyme process, the denature proteins, for example, organic copper compounds. By simultaneing or interfacing with hormones, for example, phenoxy herbicides. Second is hazardous of pesticides. The pesticides industries causes pollution of soils, water, and air. The pest, pesticides reside wash along with rainwater is added to the nearby water resources,
ओके
making
श्रद्धा.
unfit for drink.
स्टॉप. ओके, व्हेरी गुड. स्टॉप,
Thank you,
स्टॉप.
ma'am.
ओके. Tell me any one example of inorganic pesticide.
uh, endosulfan,
Which element present? Metal.
uh, fluorine.
Chlorine. Chlorine is a metal.
Sorry, sorry, ma'am.
Okay, ठीक आहे. Next. Jyoti Raut.
Yes, ma'am.
Okay. Share your screen. राऊत स्क्रीन शेअर करा तुमची. ओके डन. दोनशे बारा ना.
Ma'am, screen is visible.
येस येस विजिबल.
Uh,
तुमची जे काही पीपीटी किंवा जे काही पेज असेल ते शेअर करा आता. मोबाईलची स्क्रीन दिसते ती विंडोज ओपन करा तुमचे जे काय आहे ते.
hello.
येस.
Screen दिसते का मॅम?
स्क्रीन दिसते फक्त शेअर करा तुमची ते जे काही सेमिनारचे कंटेंट आहे ते.
मॅम
येस लेफ्ट साईडच्या बॅक बटन वरती जावा. लेफ्ट मोबाईल मध्ये जे लेफ्ट साईडला तुम्ही डायरेक्ट बॅक जाता तिथल्या विंडोज मध्ये जावा. कसं ते बघा तुमचं काय. हा ओके ओके बरोबर आहे. काय टॉपिक तुमचा?
हा दिसते का मॅम आता?
येस दिसते.
My name is Raut Jyoti. Roll number 5378. My seminar topic name is refining of raw sugar. It, refining of raw sugar refers to decolorization of light brown raw sugar to produce white sugar. It involves following unit operations. First is the affinations. The raw brown sugar is mixed with heavy mother liquor of 60 degree to 80 degree bricks. Then mixing it in special vessels from called mingler provided with a stirrer. Then then the sugar crystals goes into mother liquor. The mixture is now centrifuged to separate the crystals from mother liquor, and the crystals are washed with hot water. Then washed sugar is melted in water to density 55 to 60 bricks. Then vessel used for melt, melting is melter. The syrup is sent to defecations. Defecation is the second process. Then, then the sugar solution at the stage contain insoluble impurities like clay, gums, etc., which have accept clarification during raw sugar manufacture. Then, uh, then syrup, then syrup in both liming, sulfidations, and carbonations can be used. The treated liquor goes in the defecation tank. Then third process is the declaration. The filtered liquid obtained in a step defecations in clear and dark now liquid still containing some dissolved dissolve impurities. So the liquor is passed through the beds on bone charcoal kept in a jar tank. Then the mm, then the syrup is a clear dilutions in vacuum pan. Activated carbon process activate then activated carbon process the sulfur in the syrup becomes diluted due to desiccations. So it is sent to in a vacuum pan where it is concentrated under reduced pressures. The mosquito so produced is sent to crystallizer. The sucrose crystals are separated by centrifugations. It is washed, it's dumped in wet sugar container. The mother liquor left after sucrose crystallizations is used for refining fresh.
Yes, Rahul?
Then last is the drying process. Sugar thus obtained contains 1 to 2% moisture, so it is dried in a granulator. A
Okay.
granulator
Stop.
is a horizontal.
Okay, Rahul. Stop. Tell me molecular formula of sugar. कुठल्या पण एका सांगा. Yes.
Sorry,
Tell
ma'am.
me. Tell me molecular formula of sucrose. Sucrose.
C6H4. Sorry, ma'am. C6H12O6.
O6. Okay, ठीक आहे. Thank you. Next. Aniket Raite.
Thank you.
Yes, madam.
Yes, share your screen.
Madam, the screen is visible.
Yes, visible.
Good afternoon, all of
Good
you. My
afternoon.
name is Aniket Marutiraite. My roll number is 5381. My ID number is 2018 10 213. My seminar topic is Faraday's Law. Introduction. It states that induced voltage in circuit is proportional to the rate of change over time of the magnetic flux through the circuit. In other words, the faster the magnetic field changes, the greater will be the voltage in the circuit. The circuit diagram is shown below. Induction. Faraday's law of induction. Faraday's law of the induction states that when the magnetic flux through a loop is changing, there is an induced EMF in the loop given by E is equal to d alpha upon dt. You get the sign of the EMF from Lenz's law. The diagram of the Faraday's law of induction are given below. Statement of the Faraday's law. Faraday's law of induction states that the EMF induced in current directly proportional to the rate of change of the magnetic flux through the current. Faraday's law states that the absolute value of magnitude of the circulation of the electric field around a closed loop is equal to rate of change of magnetic flux through the area enclosed by the loop. Types of Faraday's law. Faraday's law electromagnetic induction consists of two laws. The first law describes the induction EMF conductor and the second law quantifies the EMF produced in conductor. There are two types of Faraday's law are as follows. Faraday's first law and Faraday's second law. Faraday's first law. Faraday's first law of electrolysis states that the mass substance depend at any electrode is directly proportional to the amount of charge passed. Faraday's second law. Faraday's second law of electrolysis states that the masses of different ions liberated at the electrode when the same amount of electricity is passed through different electrolytes are directly proportional to their chemical equivalent. Importance of Faraday's law. Faraday's law electromagnetic induction is a very important principle. Most of the electric power in the world is generated by using the principle. Transformer used in a step-down transformer with primary coil connected to main with turn ratio produces 6 to 10 voltage across the secondary coil. Faraday's law induction is one of the important concepts of electricity. It is the look At a way, changing magnetic field can cause current to flow in wires. It is used concept of understand that changing a magnetic field can create voltage. Thank you, madam. Hello.
Yes, thank you. Right there. Next, Kajal Sawant,
Yes, ma'am.
share your
दिसते मॅम.
yes,
हॅलो.
दिसते. Yes, yes, yes.
Good afternoon. My name is Sawant Kajal Anil. Roll number 5397. UID number 2080 10 214. पहिल्यांदा आपण बघणार कंटेंट मध्ये इंट्रोडक्शन, टाइप ऑफ पॉलिमर, क्लासिफिकेशन आणि रेफरन्सेस. तर इंट्रोडक्शन काय? माय सेमिनार टॉपिक इज पॉलिमर केमिस्ट्री. इंट्रोडक्शन मध्ये बघणार आपण डेफिनेशन. पॉलिमर इज अ लार्ज मॉलिक्यूल. लार्ज मॉलिक्यूल म्हणजेच काय? तर मॅक्रो मॉलिक्युल्स. मॅक्रो म्हणजे लार्ज, composed of repeating structural unit connected by covalent bond. कंपोज्ड रिपीटिंग स्ट्रक्चरल. थोडक्यात काय तर पॉलिमर म्हणजे एखादी साखळी असते. जसा एक साखळी झाल्यानंतर त्यात दुसरी असते, तशी तिसरी असते, तशी चौथी असते, तसंच ते रिपीट होत जातं आणि कनेक्टेड असतं कोव्हॅलंट बॉन्ड मध्ये. एक्झाम्पल पॉलिव्हिनिल क्लोराइड, पीव्हीसीच्या पाईप किंवा ब्युटॅडाईन. द वर्ड डिराइव्ह फ्रॉम द ग्रीक वर्ड पॉली मिनिंग मेनी अँड मेरोस मिनिंग पार्ट. दोन वर्ड पासून तयार झालाय पॉलिमर. म्हणजे पॉली म्हणजे मेनी आणि मेरोस मीन्स पार्ट. दे आर कॉम्प्लेक्स अँड जायंट मॉलिक्यूल अँड आर डिफरंट फ्रॉम लो मॉलिक्युलर वेट कंपाऊंड. जायंट मॉलिक्यूल म्हणजे राक्षस रेणू, ते डिफरंट असतात जास्त कमी वजनच्या कंपाऊंड मध्ये. मॅक्रो मॉलिक्यूल म्हणजे लार्ज मॉलिक्यूल कशा मेडअप असतो तर स्मॉलर मॉलिक्यूल वरती. त्याच्यानंतर आपण टाइप ऑफ लिंकिंग इन पॉलिमर. टाइप ऑफ लिंकिंग इन पॉलिमर मध्ये आपण पहिला टाइप आहे लिनियर पॉलिमर, दुसरा आहे ब्रांचड पॉलिमर आणि तिसरा आहे क्रॉस लिंक्ड पॉलिमर. त्यातला आपण पहिला बघणार आहोत लिनियर पॉलिमर. अ पॉलिमर इन विच द मॉलिक्यूल फ्रॉम लॉंग चेन विदाउट ब्रांचेस और क्रॉस लिंक्ड स्ट्रक्चर. लिनियर पॉलिमर म्हणजे काय तर एक चेन असते. लिनियर म्हणजे थोडक्यात एक रेषीय. त्या लॉंग चेन असते, त्याला कुठेही ब्रँचेस आणि कुठेही क्रॉस लिंक्ड नसतं. एक्झाम्पल काय? नायलॉन, पॉलिस्टर, पीव्हीसी. पीव्हीसीचं आपण जर कोपऱ्यात पीव्हीसीचं स्ट्रक्चर बघितलं तर ते लिनियर आहे, त्याला कुठेही ब्रांचेस नाही आहेत, कुठेही क्रॉस लिंक्ड नाहीये ते. त्याच्यानंतर दुसरा टाइप आहे ब्रांचड पॉलिमर. द लिनियर स्ट्रक्चर डेव्हलप मेनी साइड चेन कॉल्ड अ ब्रांचड पॉलिमर. हे तर ब्रांचड पॉलिमर म्हणजे काय तर लिनियर स्ट्रक्चरच असतं, फक्त त्याला कुठेतरी ब्रांचेस, एक किंवा दोन ब्रांचेस असतात. अ पॉलिमर चेन हॅव्हिंग ब्रांच पॉइंट दॅट कनेक्ट 3 टू मोर सेगमेंट. त्याला कुठेतरी 3 किंवा 4 सेगमेंट किंवा ब्रांचेस असतात. पॉलिइथिलीन, ग्लायकोजन, स्टार्च. इथं कोपऱ्यात जर बघितलं आपण तर इथं लिनियर स्ट्रक्चर आहे, फक्त त्याला कडून ब्रांचेस झाले फुटले आहेत आणि ते स्ट्रक्चर झालंय पॉलिइथिलीनचं. त्याच्यानंतर आपण बघणार आहे क्रॉस लिंक्ड पॉलिमर. क्रॉस लिंक्स आर बॉन्ड दॅट लिंक वन पॉलिमर चेन टू अनदर. इथे पण काय लिनियर आणि ब्रांचेसचं मिळून झालेलं म्हणजे क्रॉस लिंक्ड. क्रॉस लिंक्स बॉन्ड दॅट लिंक वन पॉलिमर चेन टू अनदर म्हणजे एक लिनियर चेन दुसऱ्या लिनियर चेनला फक्त ही झाली जॉईन झाली. आणि ती कशी झाली? कोव्हॅलंट बॉन्ड आणि आयोनिक बॉन्ड मधनं ती अटॅच ती कोव्हॅलंट बॉन्ड आणि आयोनिक बॉन्ड असतात तिथे. एक्झाम्पल मेलामाइन, फॉर्मल्डिहाइड, रेझिन एक्सेट्रा. लिनियर आणि ब्रांचड पॉलिमरलाच आपण काय म्हणतो? थर्मोपॉस्टिक मटेरियल. क्रॉस लिंक्ड पॉलिमरलाच आपण म्हणणार आहे थर्मोसेटिंग मटेरियल. आता क्लासिफिकेशन मध्ये 4 टाइप आहेत. नॅचरल अँड सिंथेटिक पॉलिमर, ऑर्गॅनिक अँड इनऑर्गॅनिक पॉलिमर, थर्मोप्लास्टिक अँड थर्मोसेटिंग पॉलिमर, प्लास्टिक, इलॅस्टोमोर, फायबर्स अँड लिक्विड्स, लिक्विड रेझिन. नॅचरल आणि सिंथेटिक पॉलिमर म्हणजे काय तर नेचर मधून इझिली अवेलेबल झालेलं मटेरियल आहे, त्याला आपण नॅचरल म्हणणार. आणि सिंथेटिक म्हणजे काय तर लो मॉलिक्युलर वेटमध्ये सिंथेसाइज झालेलं त्याला सिंथेसाइज. नॅचरलमध्ये एक्झाम्पल काय आहे, ऊल, सिल्क, रबर हे आपल्या नेचरमध्ये इझिली अवेलेबल असतात. पण
सावंत,
सिंथेटिकमध्ये
काजल सावंत, स्टॉप.
येस मॅम.
व्हेरी गुड, व्हेरी गुड,
थँक्यू.
व्हेरी गुड.
थँक्यू.
Nice explanation.
थँक्यू.
Okay, tell me any one example of present coordinated bonded polymer.
प्रेझेंट
कोऑर्डिनेट बॉन्ड प्रेझेंट असलेलं पॉलिमरचं एक्झाम्पल सांगायचंय.
नाही माहित मॅम.
ओके, ठीक आहे. व्हेरी गुड. ठीक
थँक्यू
आहे.
मॅम.
नेक्स्ट, सिमरन सय्यद.
Present, ma'am.
ओके, शेअर युअर स्क्रीन.
Yes, ma'am. Ma'am, is it my screen visible to you?
येस, येस.
Okay. First of all, good afternoon, everyone. My name is Simran Chaukat Sayyed. My roll number is 5399 and UID number is 2018-10-215. Class BSc 3rd Division D. My seminar topic is heat treatment on the steel. First of all, what is meant by heat treatment? First, heat treatment is the process of heating steel under the specific condition of temperature so as to modify their properties is known as the heat treatment on the steel. म्हणजे heat treatment म्हणजे काय, जेव्हा आपण स्टीलला हीट करतो तेव्हा त्याच्या प्रॉपर्टीज मध्ये जो बदल होतो त्यालाच म्हणतात की हीट ट्रीटमेंट. हीट ट्रीटमेंट इज ब्रॉडली divided into four main types. First is the annealing, second is the hardening, and third is the tempering, and fourth is the surface treatment of the steel. And the first main treatment of the heat, first main treatment of the first main treatment is annealing. What is meant by annealing? The process of heating steel to the bright red hot and then cooling it slowly is known as the annealing. Due to the process of the annealing, steel becomes soft and palatable. Annealing is the most used process in the heat treatment of the steel. Due to the process of the annealing, the steel become very brittle and it is more useful than the wrought iron. Wrought iron is the most impure form of the iron. Second most important method is hardening. Hardening is the process of heating steel to the bright redness and then cooling suddenly by plugging in oil or water. It is also called as a quenching. It is also called as quenching. In this process, the steel becomes hard and brittle. Third most important process of the heating steel is tempering. The process includes the process of heating the hardened steel to temperature much below the redness and cooling. It is slowly to known as the tempering. As a result, this process does not make the steel much so harder or much so bitter. Just like that, it is like a neutral product, not so hard or not so bitter. And third important process of the heating of the steel is that surface treatment of the steel. And the surface treatment of the steel contains two main processes. First is the case hardening, and second is the lightening. And the first point is hardening, and the case hardening is the process of giving a thin layer coating of hardened steel to the flexible, strong milled by heating it in contact with the charcoal and quenching in the oil is called as a case hardening. Due to in this process, the thin coat is given to the steel and steel become more hardened and a thin layer of metal is implanted on the steel. Such can it improves its corrosion. It improves its corrosion property and also it improves its mechanical strength. And second process is the nitrating. Nitrating is the process of the heating steel in the atmosphere of ammonia is with the hard iron and nitrate. So these are the four main process of the heating of the steel. Due to the heating of the steel become more useful. Their corrosion intensity also increase. It is also used in the market in various ways. So, heating of the steel is the most important method for the method in the commercial process of the steel. So, this is all about the heating of the steel. Thank you for cooperating.
Okay, okay. Very good. Thank you. Next, Ashish Shirke.
Miss, I didn't notice it.
ओके, ठीक आहे. पॉइंट तो काय असेल तो एक्सप्लेन करा.
Okay. Good afternoon to all. My name is Ashish Shukre. Roll number 5404. UID number 2018-10-218. My title name is Electrical Industry. And so I will tell you my information to you. The electrical equipments and accessories industries with its highest
शिर्के रोल नंबर परत सांगा.
5404.
5404.
Shall I
आणि
continue now?
टॉपिक नेम.
Topic name electrical industries.
ओके.
Can I continue?
Yes, to be continue.
The electrical equipment and accessories industries, with its highest diversified contents, may be broadly segmented into three equipments. First, generation equipment, second, transmission equipment, and third, distribution equipment. The equipments are accessories under these segments includes motor, generators, switchgears, transformers, circuit breakers, and etc. Besides this, the spectrum covers a whole range of power cables, including XLPE and AAC and ACSR conductors, and electrical consumer products like fan, electric lamps, and domestic appliances and accessories, inverters. UP also falls under its domain. Thank you.
ओके. नेक्स्ट अक्षय शिंदे.
Yes, Miss.
ओके, शेअर युअर.
Hello, Miss. मिस मी पण पीपीटी म्हणजे मला पीपीटी प्रेझेंट करता आलं नाही माहिती मिस. मी फक्त सिनॉप्सिस हे केला, फिलअप करून केला,
ओके, ठीक आहे.
ऍड फाईल करून
रोल नंबर
सबमिट
सांगा
केला फक्त.
तुमचा. रोल नंबर
5406.
5406. ओके, टॉपिक नेम सांगा.
हॅलो मिस. फर्स्ट ऑफ ऑल
ओके.
गुड आफ्टरनून ऑल ऑफ दिस.
टॉपिक नेम
माय
सांगा
नेम
आधी.
इज
टॉपिक नेम सांगा.
ओके ओके ओके. पेपर रिसायकलिंग.
हेट्रोसायक्लिक.
नाही नाही नाही, पेपर रिसायकलिंग.
ओके
रिसायकलिंग.
ओके, ठीक आहे.
Good afternoon, all of. My name is Shinde Akshay Sauta. Hello. Hello, Miss.
येस बोला,
माझा
कंटिन्यू
आवाज
करा.
येतो का?
येतोय आवाज. येस
Okay.
येतोय.
My roll number is 5406. My number is 2018-10-219. My title name is Per Recycling. Paper recycling. The recycling of paper is the process by which waste paper is turned into new paper product. It has a number of important benefits. It saves waste paper from occupying homes of people and producing methane as it breaks down because paper fiber contain carbon originally absorbed by the tree from which it is produced. Recycling keeps the carbon locked up for longer and out of the atmosphere. Around two-thirds of all paper products in the US are now recovered and recycled, although it does not all become new paper. After repeated processing, is the fiber become too short for the production of new paper. How does it work? The process of waste paper recycling most often involves mixing used old paper with water and chemicals to break it down. It is the uh, it is heated, which break it down further into strand of cellulose, a type of organic plant material. This resulting mixture is called pulp or slurry. It is strained through screen, which remove plastics, especially for plastic coated paper that may still be in the mixture, then cleaned, delinked, linking, remove, bleached and mixed with water. In India, the environmental impact due to excessive use of paper has negative effect on trees and forests. Paper production utilizes nearly 40% of world commercially cut timber. Millions of acres of forest are destroyed, leading to deforestation, disturbing the ecological balance. Many entities are being taken in India for recycling paper and reducing the hazard association with it. Sri Aniruddha Upasana Foundation in Mumbai, India, is one such organization which undertakes used paper recycling project. Thank you, Miss.
Okay, very good. Next, Atharva Shinde.
Yes, ma'am.
Yes. PPT आहे.
नाही मॅम.
ठीक आहे. रोल नंबर सांगा आधी तुमचा.
5409.
09. ओके. टॉपिक नेम सांगा.
नॅनो मटेरियल्स.
ओके. कंटिन्यू.
Hello friends, my name is Atharva Shinde. My synopsis name is Nanomaterials. Uh, in 1959, Dr. Richards Feynman presented in idea of building materials atoms by atoms, and this is idea evolved into new branch of science which is called as nanoscience. So what is nanoscience? So and nanoscience deals with building up complex materials and machines using fine control on the matter at the nanomaterial scale. So is nanoscience we will be studying properties of material having the length scale of the order of few nanometers. For example, if we compare calculate the size of the volleyball, it can be calculated in cm. The size of the ant can be measured in mm. The diameter of the size of bulb cell in 10 micrometers. The values can be measured at 100 nm nanometers. DNA around 10 nm. So is nanotechnology. We will deals with materials in the size range in 1 nm to 100 nm. So 100 nm. Size depend of properties of nanomaterials, optical properties and semiconducting properties. Properties of nanomaterial, which are the important physical and chemical properties of nanomaterial. Physical properties: size, shape, specific surface area, accept ratio, size distribution, solubility, chemical properties, structure formula, molecular structure, phase identify, uh, hydrophiction, lithophysi. Thank you.
ओके. थँक्यू. नेक्स्ट, अजिंक्य शिंदे. नाही सॉरी, श्वेता शिंदे.
येस मैम.
ओके. पीपीटी के लिए.
हाँ के लिए मैम.
ओके, शेअर.
दिसते मैम.
येस
मॅम.
येस दिसते. येस दिसते.
माय नेम इज श्वेता अशोक शिंदे. रोल नंबर 5421. UID नंबर 2018-10-224. क्लास BSc थर्ड डिविजन बी. माय सेमिनार टॉपिक स्टील अँड टाइप ऑफ स्टील. डेफिनेशन ऑफ स्टील. इट इज. मॅम आवाज येतोय ना?
हो येतोय.
Definition of steel: it is the most important from commercial iron by removing some carbon along with sulfur, phosphorus, silicon, or by adding the required quantity of carbon to root iron. Steel is free from phosphorus, silicon, and sulfur. Physical properties depend upon chemical composition and also heat treatment. Type of steel: on the basis of quantity of carbon present in steel, type is further divided into mild steel. Second is medium steel. Third is high carbon steel. First is mild steel. This type of steel contains less than 0.2% of carbon content. It is a malleable, ductile, and used in place of wrought iron. It is used in boiler, plates, rivets, etc. Second is medium steel. Medium steel contains carbon content 0.2 to 0.6%. It is used for making rare structural elements such as grider beams, etc. It is also called as structural steel. Third, high carbon steel. This type of carbon content ranging from 0.75 to 1.5%. It is also called as hard as to steel and used for making tools, files, surgical instrumental, razors, drills. This type of steel can be also obtained by quenching the mild steel. Second is alloy steel. Alloy steel is defined as the steel when alloyed with at least one other element than carbon in sufficient quantity of contain special properties on it is called alloy steel. Elements used for purpose are silicon, vanadium, titanium, chromium, manganese, tungsten, cobalt, nickel, etc. They are added to the molten steel in the electric furnace. First is manganese steel. This type of steel contains 1.2 1.7% manganese. It has a tensile strength. Second is nickel steel. Nickel steel contains about 2.5 to 5% nickel. It has a greatest toughness and elasticity. Thank you, ma'am.
ओके, थँक्यू. नेक्स्ट अजिंक्य शिंगटे. अजिंक्य शिंगटे. हॅलो. ओके, अंकिता शिंगटे.
येस मॅम.
शेअर युअर स्क्रीन.
मॅडम मी काल सिनॉप्सिस सेंड केला, पीपीटी नाही केली.
बरं ठीक आहे, तुमचा रोल नंबर सांगा.
मॅम आहे मी. मॅम अजिंक्य शिंगटे.
ओके, घ्या मग. चला तुम्ही आधी शेअर करा. ठीक आहे, थांबा जरा तुम्ही. 54-25. ठीक आहे.
हां.
अजिंक्य शेअर करा तुमची स्क्रीन. पीपीटी केली आहे?
हो केली.
ओके.
Am I audible, ma'am?
Yes, yes. Visible.
First of all, good afternoon, all everyone. My name is Ajinkya Shingte. My roll number is 5425, 54, 25. My ID number is 2018 10 20 20 to 225. Now, we are started on the basis of physical, mechanical properties and a chemical composition. Steel may be divided into two classes. One, carbon steel, and second, alloy steel. First of all, we all see carbon steel. On the basis of quantity of carbon present in the steel, this type of is further divided into mild steel, medium steel, and high steel carbon. My steel. This type of steel contains still less than 0.2% of carbon content. It is malleable, ductile, and used in the place of wrought iron. It is used in boiler plate. Second, medium steel. Medium steel contains carbon content 0.2 to 0.6%. It is used for making rails, structural elements such as grinder, beams, etc. It is also called as structural steel. Third, high steel carbon. This type of carbon content ranging from 0.75% to 1.5%. It is also called as hard or tool steel and used for making tools, files, surgical instruments, razors, drills. This type of steels can be also obtained by quenching the mild steel. Now second, alloy steel. Steel when alloyed with at least one other element than carbon in a sufficient quantity of confer properties on it is called alloy steel. Element used for this purpose are silicon, vanadium, titanium, chromium, molybdenum, manganese, tungsten, cobalt, nickel, etc. are used in the production of alloys. Steel with desired physical and mechanical properties, sometimes more than one of these elements are used. Alloy steel. Generally, they are added to the molten steel in electric furnace. On the basis of chemical composition, physical and mechanical properties, alloy steels are further divided into a large number of subtypes. Manganese steels. This type of steel contains 1.2 to 1.7% manganese. It has a tensile strength and extraordinary resistance to wear. It is used for making railroad switch points, jaws of roads, friendship of machinery, bulk shapes, etc. Second, nickel steel. Nickel steel contains about 2 to 2.5 to 5% nickel. It has greatest toughness and elasticity. It is used for making crankshafts, gears, heavy guns, airplane parts, etc. Third, in war, nickel steel containing about 3.35% of nickel with little manganese and carbon is called in war. It is coefficient of expansion is very small and hence used for preparation of pendulum rods, balance wheels of coaches. Fourth, chromium steel. This type of steel contains about 2% chromium. It is extremely tough and hard and hence employed to make cutting tools, ball bearings, armor plates, etc. Fifth, stainless steel. Stainless steel contains about 12 to 15% chromium with 0.3% carbon and it resists to the action of organic acids. It is used to make stainless cutlery, cycle automobile parts, etc. 6. Chromium vanadium steel. This type of steel contains about 0.15% of vanadium and about 1% chromium. It is largely employed in the manufacture of motor car frames, locomotive wheels, gears, springs, etc. 7th, chromium nickel steel. When this type of steel contains about 3% nickel, 1.5% chromium, 0.3% carbon, then it is suited for crashing and used to construct the airplanes, motor cars, etc. When about 18% chromium and about 8% nickel is present in the chromium nickel steel, it can resist the corrosive action of seawater. Thank you.
Okay. Next, Ankita Shinte.
Yes, ma'am. Good afternoon. My name is Shintan Kira Santosh. Roll number is 5426. ID number is 2018 My the topic name is areneous acid and areneous base. Areneous acid means that it dissociates to produce an excess of hydrogen ion in solution. In areneous acid, in the aqueous solution increases the concentration of protons of hydrogen ion. For example, hydrochloric acid in the water. Hydrochloric acid undergoes dissociation reaction to produce H plus ion and Cl minus ions. The concentration of H plus ion is increased by forming hydronium ion. The first reaction is HCl aqueous gives H plus aqueous plus Cl minus aqueous. Second reaction is NHO3 aqueous plus H2O liquid gives H3O plus NO3 minus. In this reaction, nitric acid dissolves in aqueous water to give hydrogen and nitrate ions. The example of areneous acid is hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, and acetic acid. The areneous base means it dissociates to produce an excess of hydroxide ion in solution. An areneous base is a substrate that increases the concentration of hydroxide ions in the aqueous solution. The example of areneous base is highly soluble sodium hydroxide compound in water, which dissociates to give sodium ion and hydroxide ion. In the aqueous solution, sodium hydroxide completely dissolved to give hydroxide ion and sodium to increase the concentration of hydroxide ions. Some other examples of areneous bases are first and second group hydroxides like lithium oxide and BaOH2. In this above reaction, lithium hydroxide dissolves in water to give lithium ion and hydroxide ion. The examples of areneous bases sodium hydroxide, potassium hydroxide, calcium hydroxide, and magnesium hydroxide. Thank you, ma'am. Madam.
Okay. Next, Mayuri Sonane.
Yes, ma'am.
Mayuri PPT आहे?
Yes, ma'am.
Okay.
Good afternoon, everyone. My name is Mayuri Sonone. My roll number is 5430. UID is
2018 10 227. My seminar topic is Manufacturing of Wax Candle. Introduction. A solid wax structure with a wick in the middle is known as candle, used to provide light and heat. Candles have been used for generations to light and brighten one's celebration. History. The earliest surviving candles organized in Han, China around 200 before Christ. These early Chinese candles were made from whale fat. During the Middle Ages, tallow candles were most commonly used. By 13th century, candle making had become guild craft in England and France. Raw material for manufacturing of candle. Candle wax can be mineral, animal, or vegetable. The most common raw material used in candle production today are paraffin, beeswax, and styrene. They are all components of nature and proceeds by means of elaborate process in such a way that they offer the required properties. Process for manufacturing candles. First step is measure the wax. Before you begin the candle making process, make sure you have a clean flat surface to work on. Measure out how much wax you would need to fill your container, then double it. Second step is melt the wax. Pour the wax into your double boiler and allow to melt for 10 to 15 minutes with constant stirring. Step third, add fragrance oil. When your candle wax is melted, it's time to add fragrance oil. While this step is optional, we definitely recommended it for lovely floral smell. Step 4. Attach the wick. The wick needs to attach to the bottom of your container. Before you pour in the wax, you can attach the wick by dipping it in the melting wax, then quickly sticking it to the bottom of the container. Let the wax sit 5 minutes to harden. Alternatively, you can superglue it. Step 5. Pour the wax. Before you pour the wax into your container, let it cool for few minutes. When the temperature on thermometer reads 140 degree, it's time to pour. Then slowly pour the wax into your container. Hold the wick in place, but don't pull on it. Leave a small amount of wax in the boiler for topping of your candle later. Processing. Secure the wick. To prevent wick from swaying in the melty wax, you need to secure in its place. Allow the wax to set for 4 hours at room temperature. Step 7 is add more wax. If your candle hardened with an unsightly top, simply reheat and add your remaining wax and then let harden. Cut the wick. Your candle wick should be less than half an inch long. Uses of candles. In the developed world today, candles are used mainly for their aesthetic value and scent, particularly to set a soft, warm ambience for emergency lighting during electrical power failures for religious or ritual purpose. Thank you, ma'am.
ओके नेक्स्ट प्रतीक्षा सोनमले.
Yes, ma'am.
प्रतीक्षा ठीक आहे.
शेअर करू का मॅडम?
येस येस करा.
स्क्रीन दिसते मॅडम?
येस दिसते.
First of all, myself Soumya Pratisha Rajendra, roll number 5431, UID number 2018 10 22 8. Content: Introduction, Occurrence and Conclusion. My
seminar title is natural product, that is example आहे terpenade. इंट्रोडक्शन मध्ये फर्स्ट ऑफ ऑल नॅचरल प्रोडक्टचं आपण हे नॅचरल व्हॉट इज मीन बाय नॅचरल प्रोडक्ट. Natural product is a chemical compound or substance produced by a living organism that is found in nature. Example आहे terpenade. Natural products means it is a chemical compound. ते केमिकल कंपाऊंड आहे फक्त जे नेचर मध्ये नॅचरली लिव्हिंग ऑर्गॅनिझम पासून प्रोड्यूस होतं. दीज आर आणि त्याचं मोस्टली एक्झाम्पल आहे टर्पेनाइड. दीज आर नॅचरली ऑकरंग कंपाऊंड ऑब्टेन फ्रॉम व्हेरियस पार्ट्स ऑफ प्लांट्स. टर्पेनाइड हे प्लांट्सच्या पार्ट्स पासून आपल्याला मिळतं. All compounds of empirical formula C5H8 and their different derivatives, alcohol, aldehyde and ketones. Therefore, it having general formula C5H8. टर्पेनाइडचा जनरल फॉर्म्युला आहे C5H8 आणि तो टर्पेनाइडचा ऑकरन्स आहे इसेन्शियल ऑइल्स ऑब्टेन फ्रॉम रूट्स, बार्क्स, लीव्स, फ्लॉवर्स, फ्रुट्स, गम्स अँड रेझिन्स ऑफ प्लांट्स. मगाशीच आपण बघितलं ते नॅचरल प्रोडक्ट आहे त्यामुळे ते नॅचरली अवेलेबल होतं नेचरमध्ये. आणि हे कशापासून भेटतं तर रूट्स, बार्क्स, लीव्स, फ्लॉवर्स, फ्रुट्स अशा वेगवेगळ्या प्लांट्सच्या पार्ट्स पासून आपल्याला मिळतं. दॅट इज लेमन ग्रास ऑइल, सिट्रल. हे एक टर्पेनाइडचं एक्झाम्पल आहे. आणि कन्क्लुजन मध्ये नॅचरल प्रोडक्ट रिप्रेझेंट्स बायोलॉजिकल डायव्हर्सिटी, फंक्शनल फूड. नॅचरल प्रोडक्ट मध्ये हे जे टर्पेनाइड आहे ते बेसिकली फंक्शनल फूड म्हणून सुद्धा किंवा हर्बल मेडिसिन म्हणून सुद्धा प्लांट केमिस्ट्री अँड प्लांट डेव्हलपमेंट अँड मेटाबॉलिझम.
ओके, थँक्यू. नेक्स्ट सागर यादव. सागर यादव आहेत का प्रेझेंट? ओके, असं कोण आहे का जॉईन झाले आणि त्यांचं सेमिनार झालं नाही? येस येस
मॅम माझं राहिले प्रेझेंटेशन.
हा, एक मिनिट. यादवचं झालं की तुम्हाला विचारते.
My name is Sagar Jayant Yadav and my UI number is 2018-10-233 and my roll number is 5440. And topic of my seminar is nurse distribution law. Nurse distribution law. Nurse in 1891 studied the distribution of several solutes between different appropriate pairs of solvents. He gave generalization which governs the distribution of a solute between two non-miscible solvents. The meaning of the word non-miscible means they do not mix with each other and they form two different layers according to their density. And also this is called as nurse distribution law. We have the equation here. If the solute X distributes itself between two immiscible solvents A and B at constant temperature, then X is the same molecular condition in both solvents. We can see that concentration of X in solution A divided by concentration of X in solution B gives us the distributional coefficient which is called as KD, which can be denoted by KD. We have diagrams here. When the distribution of solute X has reached dynamic equilibrium, the rate R1 in which molecules X pass from solvent A to B is proportional to its concentration, and the rate R2 at which molecule X pass from B to A is also proportional to their concentration, which is denoted as C2. The example for this is water and ether. They are immiscible and they do not mix with each other. So if we and succinic acid is soluble in both solvents. And if we want to have the coefficient, then we have to divide the concentration of succinic acid in water to concentration of succinic acid in ether. The conditions for distribution law are both solvent must be immiscible, means they should form the different layers. This law is only applicable for dilute solutions as they are less acidic. Uh, Temperature must remain constant throughout the whole experiment because temperature could have effects on solubility. The molecular state of the two solvents should always remain same in both the solutions. The limitations of distribution law. Dilute solution. The concentration of solute must be low in two solvents. This law does not hold good when the concentrations are high. Means the solutions are when acidic. Constant temperature. Temperature should be kept constant throughout the experiment. Since solubility depends on temperature. The solubility increases with the increasing temperature and decreases with the decreasing temperature. Same molecular state. The solute must be in same molecular state in both the solvents. Equilibrium concentration. This is achieved by shaking the mixture for longer time. Non-miscibility of solvents. So solvents are allowed for separation for sufficient time. We have some mathematical examples of null distribution law that are solved by that law. So here, when benzoic acid is shaken with mixture of benzene and water at constant temperature, the following results obtained. So they gave us concentration of acid in benzene and concentration of acid in water, and we have to comment on the result. So from the calculation, we have to divide these two concentrations, and we got the answers as 16, 25, and 32. Thus, the distribution coefficient is not constant.
ओके यादव,
Therefore,
ठीक आहे, स्टॉप, थँक्यू. ओके, नेक्स्ट कोण राहिले तुमच्यातले?
मॅम हॅलो
हा, कोण राहिले?
हॅलो मॅम, मी जयश्री पवार बोलते. माझा सेमिनार राहिलेला मगाशी.
ओके, ठीक आहे. देणार आहे का आत्ता मग?
हा मॅम, ते
ठीक आहे, करा सुरू.
ओके.
धनश्री नानासो पवार ना?
हा मॅम.
ठीक आहे.
My seminar topic is manufacturing of white sugar in India. Hello ma'am. Hello ma'am.
येस, बोला.
My screen is visible to you?
येस, विजिबल.
My seminar topic is manufacturing of white sugar. White sugar. White sugar is manufactured by a single step process. The first step involved in its extraction of juice. The cane juice is extracted by combined imbibition process. And the second step is the clarification of juice. The cane juice is collected from the mill house. It contains about 78 to 86% water, 10 to 20% sucrose, 0.5% organic matter, 0.5 to 2.5% reducing sugar, and 0.3 to 0.77% ash. Besides this, it also contains fine pitch, fiber, and also some colloidal matter. They affect crystallization of sucrose and impact the color to it. So they are removed by clarification method. The clarification method is sulfonation desiccation process. It is a more efficient and faster method. The cane juice is excessively lime about 1 to 2 kg ton of cane juice. It is heated to 333 Kelvin to alkalinity. This increases the pH. This increases the pH. That results the colloidal particles and soluble phosphate salts separate out rapidly. Now sulfur dioxide is a gas Bubble the lime juice till the pH is got 7. Sulfur dioxide also helps
The juice is a colorless liquid.
the third process involved in it is concentration of juice. The clear clarified juice obtained from any of the above method is diluted to concentrated to syrup containing 45 to 50% water in triplet effect vacuum evaporator. The fourth step is crystallization of juice. The thick sugar syrup obtained from multiple effect evaporator is further concentrated to mixed liquid containing 9 to 11% water in a stick pan. The fifth process is centrifugation. The sugar crystals are separated from other liquor in centrifuge, the path followed by cane to cane sugar in single-step manufacturing process.
झालंय का पवार?
हो, थँक्यू.
ओके, नेक्स्ट अजून कोण राहिलंय का? स्वाती कादळे.
मॅम मी राहिले.
हॅलो.
येस येस, कोण?
ऋतुजा माने.
हा मिस माझं पण ठेवलं.
ओके, नाव सांगा तुमचं पूर्ण.
ऋतुजा सुनील
माझं ना
माने.
ऐश्वर्या मुरड.
एक मिनिट ऐश्वर्या, ऋतुजांचं घेते. ऋतुजा
सुनील माने.
ओके, युआयडी नंबर सांगा तुमचा.
2018-10
हा
184.
पुढे सांगा माने. 184.
2018 हा
ओके ठीक आहे, करा
5318
सुरू.
रोल नंबर.
ओके ओके.
स्क्रीन दिसते का मॅडम? स्क्रीन दिसते का मॅम?
येस दिसतेय माने.
Good afternoon, ma'am. I am Rutuja Mane. My UID number is 2080-10-184. My roll number is 5380. My seminar topic is the Sol-Gel process. Sol-Gel method is the chemical process that uses bottom-up approach. Sol-Gel is the type of collider in which solid particles suspended in a liquid. This particle, small in size, is actually heterogeneous mixture. The particle is small in size. When the solvent is the forms sol begins to evaporated semi-liquid mass that the called gel. When solvent forms, the ion left behind the begins to join together and the continuous network and from gel. So we have the Sol-Gel type of a colloidal which solid suspended in a liquid. So these are liquid evaporated and to form a gel is called as a gel. Gel is a particle of or ions left behind the joint together to form a continuous network. Second order in a property significant amount of the to be removed and can be accomplished sedimentation process and centrifugation process. The remaining liquid is removed using dried process. What you dried gel for the removal of treatment is often necessary. This may be further enhance mechanical properties of structure stability. The bright gel is grinded to find powder after further processing done by the shifting product. And final product is the decomposed substrate from the film or cast into the suitable container. The desired shape use the synthesis of powder. This process are involves the fermentation of inorganic colloidal suspension gel, the gelation of the sol in the continuous liquid phase. Advantages: Soldier approaches in cheap, low temperature technical allow the control of product chemical composition. Even small quantities of introduced in the soldier, the uniformly dispersed. Rate of reaction can be easily controlled. आपण करू शकतो. Temperature. Thank you, ma'am. हॅलो अगं तिथे मॅम हॅलो आवाजच आहे ना ते आवाजच आहे एवढं वाचलं
Ma'am, I've done.
हॅलो, आवाज येतोय?
हा
हॅलो.
हा
हा ठीक आहे. नेटवर्क हा इथं जरा पाऊस जास्त आहे त्यामुळे नेटवर्क इश्यू झालेला. करा कंटिन्यू. सॉरी.
मीच तिचं झालंय आता फक्त मी राहिलीये.
बर ठीक आहे चालेल. तुमचं नाव आणि मला इन्फॉर्मेशन द्या म्हणजे मी फिलअप करते.
हा
युआयडी नंबर
झालं.
1 मिनिट. कोण सांगतय?
ऐश्वर्या मुरारी.
ओके ठीक आहे. तुमचा युआयडी नंबर सांगा.
2018 10 388.
ओके, नाव सांगा तुमचं.
ऐश्वर्या अशोक मुरारी.
ओके, करा कंटिन्यू.
हा मी पीडीएफ नाही बनवू शकले. मी सेमिनार सांगते.
काय?
पीडीएफ म्हटलं मी कन्वर्ट नाही केलेला. सेमिनार बोलून दाखवते मी.
ओके. टॉपिकचं नाव सांगा मग आधी.
Sacher-Morse theory of stainless string.
ओके.
According to this Sacher-Morse theory of stainless ring, the ring with 6 or more carbon atoms become free from the string. As well, the carbon atoms are not forced into one plane. The carbon atoms occupy different planes where the normal triangle is written. The ring formed are called stainless ring. First, Sacher's theory. The carbon atoms of cyclone and higher alkaline are not planned but assume stain-free configuration, which in the carbon retain its normal valency angle of the angle of 109. Mohr's theory. Mohr's theory suggests the possibility of existence of two forms which are radially interconvert signed by rotation of single bond involving negatively distortions of in conversation. हॅलो.
हा येस झालंय.
हा झालं मी.
ओके, अजून कोण राहिले का नेक्स्ट? झाले सगळ्यांचे?
हा झाले सगळं. मीच राहिले
ओके ठीक
अजून.
आहे. कोण आहे अजून? नाव सांगा.
कोण नाही मी झाले मीच
हॅलो.
होते लास्ट राहिलेलं.
हो
हॅलो.
ओके ठीक आहे. थँक्यू. हा.
हा थँक्यू.
हा.